Welcome, everyone, and thank you for joining us. I'm Brenda Dettinger from BioPack, and I will be your moderator on today's webinar. This is the second part of a two-part series, Virtual Reality Simplified for non-programmers. We have a really full webinar, so I'm just going to plow through the housekeeping here. If you have questions or comments, please submit them to me through the control panel. I'll pass as many as I can on to Alex. When the webcam's turned on, you can resize it if you need to using this little gray bar right here. Heads up, the frame rate for VR is many times higher than what you see on the screen. So the video will look jerky in this webinar, but rest assured the video inside the headset and on the desktop live looks very smooth. Today's webinar is being recorded and we'll send each of you a link once that's processed. Finally, we'll have a survey at the end. Please complete that survey so we have your feedback and ideas. Now on to our presenter. Alex Demoff is a product expert and the head of sales for Europe. He has taught over 125 workshops on the topic of physiological data acquisition and analysis has been with BioPack for over 15 years. While at UC Santa Barbara, he was an instructor for the Advanced Training Institute for Virtual Reality and Social Psychology. Welcome, Alex.
Thanks. Welcome, everyone.
All right, Alex, I'm going to go ahead and make you presenter here. And here you go.
All right. Thanks for joining. So I think some of you were in part one, which was more of a showcase, where I was just demonstrating what is possible within the virtual reality platform that we offer. And this one is a little bit different because we're going to go and start from scratch and build out an experiment. And in the process, I'll be revealing tools that help you create an experiment in virtual reality. And as I mentioned, you don't have to be a programmer to do this, okay? So before I begin, just a few words about BioPack and about the virtual reality solution. So BioPack has been cited many times, over 52,000 times in scientific publications. Our equipment is used in almost all the top universities in the world. And essentially, we provide complete solutions for the lab. If you look at virtual reality, we are providing a complete lab solution that includes all the hardware, HMD, computer, etc., and the support. So everything you need to run it. If you're interested in other forms of sensory stimulation, we have tactile stimulation, we have temperature, so we can invoke the sensations of feeling cold or warm, olfactory stimulation, so we can have sense, electrical stimulation, and so forth. We can also synchronize with media, meaning that in virtual reality, we can capture the viewpoint of the participant and link this to the physiological data. And we can likewise link, just like this, we can likewise link to a video recording of the participant themselves. Here we can see the cursor in the physiological data linked to the cursor in the media. As far as software, we have really powerful software that allows you to record many different channels of data synchronized. And then we have the tools to analyze, including signal-specific tools and workflow routines for automation. Then we have options to record many different kinds of physiological signals, electrocardiogram, electromyogram, respiration, various forms of sensor data. So we can look here at different illustrations, skin conductance, pose, pressure, cardiac output, blood pressure, gas analysis, etc. We also have eye tracking solutions, and eye tracking solutions include options for eye tracking glasses, which are for the real world, head-mounted displays with eye tracking, which we use in VR, and remote eye tracking. That's when you're sitting in front of a monitor or a display device. Functional near-infrared solutions we offer both for outside VR and for VR specifically, where there are two different options. There is a prefrontal cortex only sensor, which is very thin and can fit under a lot of the head-mounted displays out there. But then if you need a lot more channels that go anywhere on the head, and you also want EEG as well, you can have EEG in addition to the FNIRS. Then we have the Medalock system, which provides high density solutions for FNIRS. And finally, there are education systems. So we have teaching systems for different kind of curriculums, and related to the topic of virtual reality, we also have immersive projection systems that can help your training and training simulation needs. Okay, so now let's jump in because we have a lot to cover. All right, so I'll be covering creating an experiment from scratch, but before we begin, I have to introduce you to the tools that I will use. Okay, so these are sort of the pieces of the puzzle. There is the VR engine, Wizard, and let me just open up Wizard, show you what it looks like. There is code in there. This is code in Python, but as I mentioned, you don't have to know how to code. In fact, for a lot of the experiments, you actually don't have to write any code. Usually, you just change certain parameters following instructions. But Wizard is the engine. That's the VR engine. That's what compiles the code and runs the virtual world. Then we have our resources for generating the experiments. Okay, so if I click here, we can see all the various resources. These are scripts for running experiments with 3D models, with 360-degree images and video. We have all sorts of resources, including environments, 3D objects, audio, avatars, and so forth. Many different examples, starting code, etc. So let's call this experiment generation resources. And then the other piece here is the inspector, which you use on the 3D models. So I'll open up the inspector. I can actually just type in here inspector. Okay, and it will open up. And going back to my folder here into the resources, I'll just grab one of the environments and I'll just put it in here in the inspector. Okay, so this inspector allows us to view the models and make changes to them, like such as, for instance, grabbing this soccer ball and then changing its position. So just kind of shifting it on the wall and so forth. And I'll be showing how that works. Okay, and then finally we have Sketchfab, which we use as the source for our 3D models. Okay, so if we come over here, we can go to Sketchfab. So we can see all sorts of different 3D models, and I'll choose, for example, classroom. Okay, make sure you click on downloadable, and then we have a lot of 3D models. We can click on any one of them, and what we do to get models into the virtual reality system is we scroll down and click download, and we always download in this format, the GLTF format. Okay, so we'll be going through these steps one by one. Notice that a lot of these are completely free to use. Some of them you have to pay for, but usually the licenses are not preventing you from running experiments, etc. So what's the plan for today? I'm going to walk you through the creation of a simple experiment. It's sort of a made-up experiment. so designed that you can have some typical components and ingredients to building virtual reality in it. So let's say we have a hypothesis to test, and our hypothesis is that grabbing and manipulating objects will then lead to better recall of those objects, okay, versus just viewing the objects. And this is how we go about to set this up. When participants come in the lab, they will first go into a world where they have to learn the controls. So what are they going to do with their controllers? Which you can see. Actually, you can't see my video, but you see it later. Just enable my camera for a second. So like here are the controllers, right? So what to do with them? What to do with the various buttons? So in the first part, you get familiar with it. So then they can actually run the experiment. In the second part, we expose the participant to an environment, which will be a living room. And in this living room, we have different kinds of objects. Okay, so we have several objects in the living room, and then you go to another iteration of the living room with different objects, and then again and again and again. So the space where you are is always the same, but the objects change. And then we have two conditions, right? In group A, the participants are instructed to grab the objects and manipulate them. In group B, they're instructed only to view the various objects around them. Once this is done, there is a final part of the experiment, the recall part. And then they're presented with all the objects plus objects that they have not seen before. And one by one, they look at the objects and they have to respond. Have you seen this object before? Yes, no, I don't know. So we test their recall. Okay, so now let's show you how these things would work, and then we'll go and create it. So I'll show you the finished thing, and then we'll go and recreate it from scratch. So first, what will the participant experience when they're learning the controls? Okay, this is pretty much essential, right? You don't want to just put participants inside the virtual world and they don't know what to do, right? So you have to instruct them somehow on what to do in there. So they will be able to visualize the controls and perform certain tasks. So let's just go ahead and I'll put on my head-mounted display here. Okay, and start. So you can see now that I'm in a virtual world that is very, very simple, but I have instructions in front of me, and that's important because these instructions are telling you what to do, what the different buttons do, and I have to teleport myself to different locations, and the researcher can observe the participant as they do this, and they can know that they are doing a good job, that they're comfortable with what they're doing. So just like you can see my screen, the researcher can see the screen of the participants. So they can tell the participant, grab the chicken right there, okay, and move it around, for example, right, and so forth. So anyway, this is the first thing that you would have to do when they go into the lab. And then we run the actual experiment. So let's show you the experiment here. And I'll run this again in the HMD. Now for the experiment, I'm just going to run the condition where you're told to grab the objects instead of only viewing the objects. And I've only created this with 3 rooms You can have many different rooms if you want many different objects and so forth, but I've done it only with several rooms. So let's show you how this would work. Okay, so we'll load up the rooms now. I'll also open up the acknowledge software. So here on the right side, we'll have the acknowledge software, which will be showing the markers as they're coming across. So you can see here, I can, within the VR software, click and markers will go to BioPack. Okay, and then I can also do screen recording. And then I'll put my name. I will be the participant. And I'll put some ID that I will make up, like today's date, for example, and something like that. Okay, and then we'll begin the experiment. So first, you see, I get instructions. This is the people who are in the condition for grabbing would get this instruction that they should grab and explore each object. If you're in the other condition, you would get instructions to only view the objects, and in fact, you won't be able to grab them. Okay, so now I have to press the trigger because I'm ready, and I can begin viewing the object. So here I am inside the world. I don't know if you can go back a little bit so you can see what I'm doing here. There's a bunch of objects in front of me. I can grab every single one of them and explore them, and that's the idea, right? With either hand, I can grab an object, and I'm encouraged to explore the objects, okay, in a very natural way. And there are several different rooms like that. So here I have different kinds of stimuli, and then here I have another one. So there's a cute little dog. There's a remote control. Okay, so there's several different objects here. Okay, and then at the end we're finished with the experiment. I will take off my headset. Okay, and in acknowledge we can see that markers were coming across. Markers are coming across when we look at different objects, when new scenes are loaded. And also there was a video that was generated. So we could link up that video. That's the video that corresponds to the capture of what I did. So that's always in the same location. So I'll go ahead and find it. It's recordings. And yeah, that's the name of the video file. Okay. So now you can see that they're linked. I can click in different parts of the video, and then that will take me to different parts of acknowledge and vice versa. Okay, so that's running the first part of the experiment. That's what it would look like to the participant, but of course you can have many more different objects. I've just created the basics. I've created only 3 different rooms with different kinds of objects. The second part of the experiment is the recall. So for the recall, these are default modules in the software that I just run. In fact, so not just to be very clear, I don't change anything here. Like I'm basically just running this. So I will run this program now, and I'll run this just in desktop, so I don't put on my HMD every single time. I can run this in desktop mode or to with one of the many supported head-mounted displays. So I'll run it in desktop mode. Okay, and objects. Now I will be presented with all the various objects, the ones that were in the scene, but some other ones that were not in the scenes. And I have to say for each one of them, if I've seen it or not. And then this is going to be a timed presentation. So I have 5 seconds for each object. So here are the objects. So we have this beer, and this was in, so I just click yes. And then we have this remote control, which was also in. So yeah, I click yes. And this one was also in, and so forth. And some of them were not in. I can make a different selection, and I can do it with my controller, okay? And then, or I can do it with the keyboard. So I'm doing it with the keyboard right now and clicking no. Like actually this remote control, that was not in. So I would definitely respond no for this one, and so forth. I'm not gonna run through all of it because there's a whole lot of objects here, but that's how it works. So I will just escape out of that. And of course, we'll get at the end, we can get the data, because once again, we can have the data saved, as well as markers coming in to acknowledge our software for recording physiological data. So we can see the choices people made along with their physiological data. All right, so let's go for our first poll before we go ahead and talk about how this is done, how this is created.
Great. All right, well, let me go ahead and launch this poll, Alex, and the rest of you, if you could take a look at this poll and answer the questions. So I do have a couple questions here from the registration flow. One of the questions is how much does this cost, Alex?
Yeah, so probably the best way to think of it is, you know, in the past, virtual reality labs were quite expensive to set up, but that's no longer the case. It's pretty comparable to the cost of setting up a psychophysiology lab where for one person you have 5 or 6 different signals you want to record. So if you're getting the hardware and software to do that, to record these signals, similar cost to add VR per person, and it scales. So I think, yeah, that should give an idea.
All righty, so doable for sure. And all right, let me go ahead and close this poll. Looks like primarily we have novice and beginners on, with a few people intermediate and advanced sprinkled in. So back to you, Alex.
All right. Okay, so now we're going to go through the steps for how we actually do that. Let's we're starting with a blank slate. We don't have anything. We need models, okay? So we have decided what the experiment is going to be, but that's all it is. So we need to find a room. So I looked on Sketchfab and I found this particular room. So just click here. Again, Sketchfab is a resource for 3D models. A lot of them free, some of them paid, but all of them have download options in a format that works with the virtual reality system. So this looks like a pretty nice, neutral living room. So let's go ahead and download it. Okay, we scroll down here and we download the 3D model. And we select this option here, GOTF, download. Okay, and let's show folder, copy, and we'll go ahead and place it here. I'll make a new folder and I'll call this webinar. Okay, and I'll paste it in. And now I will extract everything from this folder. Okay, so this is what we got when we downloaded. And this GLTF file format, if I just open it, Windows will show you the 3D model, okay? So you can have a look at it, okay? So you can explore it. But we want to do more than that. Like that's not sufficient for us, okay? We want to edit this model. So we open up the inspector, okay? And then we drag and drop inside. As simple as that. And now we can see the very same world. And we see it exactly as it will look in virtual reality. This is very important. So we can look around, see if there's any problems with it. Looks good. So the next thing we want to do is make sure that it's scaled in a reasonable way. Okay, so on the left side here, we can see what this model is made of. We always go to this part right here. It says Sketchfab model. And you can hopefully see this down at the bottom. It says size of selection bounding box, okay? And in meters, it tells you it's 6.65 meters by 4 meters by 6.3 meters. That's the dimension of this living room, which sounds reasonable. It appears to be proper human scale. Sometimes it's not. Sometimes you have to go to this uniform scale tool and you have to make it smaller or bigger, okay? And you can be also very precise with these transformations. Like I can type in an exact scale factor, and I'll just undo this now so that, because it was already looking good. But this is the first thing you have to do. The first thing you have to check when you download things from the web, they're not always exactly at the right scale. The next thing we want to do is make sure that we, as the participant, are going to actually start where we want. And I want us to be on this couch, okay? Because this is going to be a seated experience. Now you can have a standing experience, but I will have a seated experience. So to do that, let's just go back to our folder here. I'm just using a shortcut here to get to the folder where all my resources are. And in the utilities and resources, there are some avatars. And by the way, all these things are documented, right? There's a documentation for how to do these things, but we're doing the webinar, so you can also see it in action. And then we have all these avatars, like a full body avatar. And I'll just grab one of these avatars and just bring it over here. So let's go ahead and add it in, and it's right there. And I'll also change the avatar to a sitting position. Okay, so here's the avatar, but there's a problem. Okay, this is the couch, this is the avatar, and this avatar is in the middle, like it's at the origin of the world. And when we put on our head-mounted display, imagine like we are the avatar, like we will be in that spot. So currently it doesn't look right. And we have to take some steps to remedy that. One way we can do that is, first of all, let's look at the floor here and right-click on the floor, and we'll copy the 3D position, okay? So there is a X, Y, and Z axis here. You can see these faint lines, okay? There's a green line, blue line, red line. These are the X, Y, and Z axis of the world, okay? So we have to, along those, shift the room, okay, so it ends up in the right place. I'll open up Notepad and have a look here at this, and I can see right away that the whole environment is like down by 1 meter. So if all I have to do is come over here and raise it up 1 meter. Okay, now already we can see that our avatar is pretty much in the right spot in terms of height, but just not in terms of location. The rest is easy. I can just take this whole world and align it so the avatar ends up being where I want the avatar to be. That actually looks pretty good. I mean, I can make small adjustments if I want, but this looks pretty reasonable. So when we are in the world, we'll be viewing from this point. And we can make some other adjustments, like this table here, I would like it to be closer so the objects are easier to grab. Like if it's that far away and I'm at a desk and I want to reach out for the objects, that's not going to be convenient because I want to place objects on this table. So we click on the table and we always choose here the top level object, like this one right here, and then we'll shift the table. So we'll shift the table so it gets to be a little closer like this. And how we can see the bowl that was on top of the table that didn't shift along with it. Let's shift this exactly by certain amounts. So for instance, we'll make this like 0.8, for instance. So that's too much. We'll make this, let's make this 1 meter. Okay, and then we'll take this object right here, which is the bowl, okay, and we'll make this 1 meter as well. So now it's looking good. Now it's in the right place. Okay, so great. We can go ahead and save as, and we can save this whole 3D model, and we can call this a new world, for example. Okay, let's click save. All right, but we have no objects, right? So what are we going to do next? We need some objects. Just to show you what we are trying to get to at the end is the following. So if we go into the directory where I have the already created worlds, they look like this. Actually, I made a shortcut so I can find them right away. Collections, objects, open up one of the rooms. So they look like this. You have a bunch of objects already there, you see. Okay, so we need to get to the point where we have the objects. So currently we don't have those objects, and we don't need the avatar anymore because it served its purpose. So I'll delete that. I don't need this avatar anymore. Great. How are we going to get objects now? Okay, well, first of all, we have to come up with what sort of objects would make sense to have on a table. And I used ChatGPT. I asked ChatGPT what sort of objects are typically on the living room table, and I got a list. And then I was just searching for the objects online, and again from Sketchfab, downloaded all of these objects for free. And so we can see now here, if we go back, okay, these are all objects that I've downloaded. So, okay, these are all the various objects, okay? So using exactly the same process, we can get those objects inside. So let's say, how do we get, for instance, the pizza in? So we can grab it, and let's go into the world here, take the pizza object, and just drop it inside. Okay, and it's, you see it's hiding under the couch. Okay, so first of all, we'll rename this object. So I'll rename the object so that it's called, and I'll tell you why I name it like this in a second. I'll call it Yes Pizza. The reason why I put the yes is because the objects that will be present in the world, they'll have yes in front of them, and the other ones will have no in front of them. And that's just going to make it easier afterwards for when we are looking at markers, when we look at things, to know which ones are the ones that were in the world and which ones were not. And now the pizza, let's check the scale, 70 centimeters, that's a bit large for a pizza. I'll shrink it down a little bit. I'll make it something like this, 0.06. Okay, that became too big. And then I'll look for a location where to place it. So I'll just click on the table and say copy 3D position. Again, I go into Notepad, and yep, that's where I want it. So I copy and paste each one of those coordinates. This is the X coordinate, so I just paste it in, and then I have the Y coordinate, I paste it in, and then I have the Z coordinate, and I paste that in, and boom, the pizza is where we want it. Okay, I press the Z key to automatically zoom in on the object. So in the same manner, I can keep adding more and more objects. I can keep downloading those objects from Sketchfab, from the internet. Already, we have quite a lot of objects that are present as starting objects in the world. So I used some of those as well. So if we come here into our resources, objects, we can see that some of those objects, like for example, the beer bottle was taken straight from here. So just drag and drop into the very same place. Okay, now, in addition, we can make some extra modifications to this world. I may want to keep track of whether people are looking at distractions. So this TV, for example, could be a distraction. I could, in fact, make it play a movie. I haven't done it now, but we could do that. So the TV is potential distraction. So if we want, we can turn it into a region of interest. So we can turn it into a region of interest in this manner. So insert above it a group, and then we'll call this, let's rename this, and it will be called TV, okay? And now this is a region of interest. All right, now this very simple world, we can immediately have a look at it to see how it performs, what it looks like. So I can save it again, and I can actually place it in a, so webinar, new world, okay, and I'll go ahead and drop it into the folder where all the worlds are kept. So let's just come over here into utilities, resources, environments, and I'll drop it in there, a new world. Okay, now if I go back to our VR engine, I can just run it. Okay, and I can be doing this with the MetaQuest Pro. So the idea is that like when I go inside the world, I will also have eye tracking functional, meaning that if I look at the TV, if I look at the pizza, those will be registered, and those can go, of course, also as when we look at objects, those can be sent as markers to the acknowledged software. Okay, so we get this interface here. I will not do any of the screen recording. I won't do any of the markers. I choose the world. It's called a new world. And let's click on this configure button here. Okay, so if we click on the configure button, we can see, yeah, the TV is going to be region with fixations, also the pizza. This is the entire model. We don't need that. I can enter my information here if I want to. Okay, and let's go inside here. All right, so we go inside the world, and now I will look at the pizza. So you should be seeing somewhere in the lower left corner of the screen that I'm looking at the pizza, and now I'm looking at the TV. Now I'm looking at the pizza, and I'm looking at some other stuff. Okay, so you can quickly check what you have, right? How it performs in virtual reality. How does it really look? It's very important as you're setting it up to see if it's matching your expectations. Okay, so yeah, let's use this opportunity to have our next poll.
Okay, here we go. Let me go ahead and launch this poll. And I'll take our next question here. Any kind of subscription needed for this, or is it possible to use it without a subscription?
I could not hear it. Can you go louder?
Oh, okay. Hello, hello. Any kind of subscription needed for this, or can we use it without a subscription?
Oh yeah, there is no subscription. I mean, these are perpetual licenses that come with the virtual reality system. You can, of course, you can buy support on a continued basis, so you can get like an extra level of support with it. But it's not going to stop working. So the license is perpetual.
Okay. Great. Okay, so then I'll go ahead and close the poll, just letting you know about 1/3 of the people say it's important, and 2/3 yes, could be interesting, and a super small percentage saying no. So back to you, Alex.
Okay, thanks. All right. So we essentially repeat this step a number of times to end up with the 3 different rooms that we have. Okay. I'm not going to go and do that. I can tell you that it's probably everything from start to finish, all the things that I had to do to complete an experiment takes about a day's worth of work. A lot of it is working with the 3D models, choosing the 3D models, putting them in the right places, and so forth. That's usually the part that takes the most time. Now, you've created your 3 models, right? So the 3 models are right here. So we go to collections, objects. So I have the 3 rooms, which actually each room is the same room, but I have different types of 3D objects laid out, just to show you again, okay, visually. Right, so this is another one of the rooms, but with different objects. By the way, I'm loading lots and lots of files at the moment. So anyway, we can see here what this looks like. Great. So what do we do next? Well, we want to have, for the different people different participants who are part of this study, we want to present multiple trials and you want to have them randomized. So the way this works, if we come back here to the code right here, okay, we always have a configuration file called media configuration, okay? And if we scroll down over here, we can see randomize, okay? We can have randomization false or true, okay? So we can either present these objects in a fixed order or they can be randomized for every participant. So you can change that option just by changing that single line there, okay? And the other thing is we want to have on-screen instructions telling participants what to do. So how do we configure the on-screen instructions? So there is very specific code that has to be added. Okay, again, this is simply you take this from the tutorial and you copy and paste this code that I've highlighted in yellow. So like we have exact instructions for where you have to paste it. So if we go inside, this is what drives the entire experiment, and then we scroll all the way down, okay, and you will see that this is the same as this, okay. So this code right here, just you have to copy and paste from the tutorials, copy and paste into your world, into your experiment. Once you copy and paste, you can modify. You see, these are the instructions that were on the screen. Find all the objects in the room, grab and explore each object, press trigger when ready. That's it. So that will result in a screen in front of the participant that they have to view so they know what to do. And you can make additional modifications by changing the actual instructions files. The additional modifications would usually be things like changing the color and the size of the font. Okay, that's about it. All right, so it's very little that you need to change, and then boom, you have instructions as a part of your experiment. And then the randomization, you can turn it on or off by just changing this media configuration. Okay, and I was going through a graphic user interface for setting up all the options, whether to send markers to BioPack's software, acknowledge whether to record a video, what objects will be grabbable. This particular part was actually done manually. So you can see here, what I've done is when I've created the objects, I've told the system basically I have room 1, room 2, and room 3. And within each one of those rooms, there are objects that I want to be grabbable. Like all these objects are going to be grabbable, okay? The baseball, the beer, the book, the candle, and so forth. And the way I get those names is if we go inside room 2 here. Okay, so let's go to room 2. And I'm collapsing all the objects. These are their names, okay? So I'm just copying and pasting those names. So I'm basically instructing the system, yeah, for room number 2, these objects must be grabbable, okay? And this is now how we can make the difference between the two different conditions. So we can have for half the participants this missing, right? So we don't have anything that's grabbable. So all they can do, even if they did not pay attention to the instructions, is just view the objects. But the moment we have these lines in here, listing all the objects that can be grabbable, then the participants can grab the objects. Okay. The synchronization with acknowledge, as I mentioned, is driven by simply checking a box, and you're automatically sending in markers to the acknowledge software, and those can come in when the scenes change, when you look at different objects, etc. So that is completely integrated. Okay, and then we also have an option for recording face tracking data. So the head-mounted display of the MetaQuest Pro, which is the default one, which we provide with the system, also records face tracking data. So we can see here what this looks like. Okay, so we have a whole lot of information on face tracking. So this data can then be saved in text format, and you can either analyze by itself, or you can actually import it into Acknowledge along with the physiological data. So you have information of whether you are lowering or raising your brows, etc. All these different units on the face as the experiment's going on, synchronized with the markers, synchronized with the physiological data. Here you can see a list of many different parameters. I've just sort of put it out there as a one very big list, but it's a lot of data, and that's available to you as well. So let's take another poll, and I'll explain how I've done the second part of the experiment, which is the recall phase.
Great. All right, here we go. We're launching the poll. So we have a slide about this later, but basically BioPack will come to your area on site, and we can host a 1-day or 3-day or up to 5-day workshop. And so if you're interested in hosting that on the topic of VR, possibly other topics as well, let us know here, and we'll have someone reach out to you. Or even if you're just interested in attending, then we'll let you know when something comes to your area. Lots of people interested in attending, a smaller segment of people, but still a lot of interest actually, so in hosting. And while that is going, let me just ask this question from Natalie. Does the program work with most VR headsets, or does it only work with a certain one?
Yeah, I'll show a picture. Maybe this will
Okay,
be
hang on.
easy.
They're
Yeah.
still responding to the poll.
Okay, but yes, I can in the meantime respond to that. It works with a lot of different head-mounted displays. Okay, I can read them out in the meantime. So in addition,
It's
like
okay.
all the
I can close the poll now. I think we got most
okay,
everybody
yeah.
responses. Okay, here we go. I'm closing the poll. So back to you.
So here, these are some slides that I showed during part 1, but because there is so much information now, I did not show them in the second part of the webinar. But here are some compatible HMDs and some other peripherals, but all the Meta/Facebook ones, HP Omnicep, Vives, etc. Right? So it's a pretty long list. And that's the beauty of it, is you design your experiment and then you just can run it for different types of hardware. So you don't have to rewrite the experiment, so to say. Okay, all right. So now on to how we did the second part of the experiment, which is the recall. So during testing the recall, the paradigm is a little bit different. Now we want to present one object at a time. Okay, so let me show you here what I did. So we'll go to part 2, resources for part 2, and actually this is the raw files, objects, source. Okay, all right. So if you want to present just objects by themselves, by default, they will appear at the origin, like at the origin of the world. And that's no good, because I'm sitting here and one after another, I'll see objects, but they'll be down on the ground, like right where I am. So let's choose one of the objects, and I'll open up the inspector. Okay, like this. Okay, and I'll bring it in. Let's see what we got here. This is a planned object. Okay, and again, this is typical of what will happen when you download things online. You see, it's like way below the plane of the ground. It's just completely in the wrong place. So, and it's also probably the wrong size. So we have to check here. Oh, the size is good, 35 centimeters by 27 by 37 centimeters. That's nice. Okay, and what we have to do next is, let's first place it at the origin. And to do that, we check here. It's just completely not at the origin. So I change everything to 0, and there we have it. It's like right here. It thinks it's at the origin, but it's not, because there is some sort of offset with this 3D model. This here is the origin of the world, like right here. So there's a little trick. I can go and look at the bottom of this object like this and copy 3D position. And now I know that it's offset by this much. So if I reverse everything, so I take these values, and instead of a minus sign, I put a plus sign here and start modifying. So paste it in, okay? And then I take this one, but I take it with a minus sign, okay? And then I take the Z coordinate, that's actually pretty much 0, so I don't have to do anything, and press the Z key. See, now I am really truly in the middle. And if I can hit F3, I can also go in wireframe mode, but you can see that like it's right there. It's in the middle of the world. Now, same as we did before, we'll bring in an avatar. So let's just bring in an avatar here. We'll go to our resources, avatars, body, and we'll get an avatar. It's very important to bring in the avatar because then you get an idea of how things look with respect to each other. Otherwise, you're just blindly placing things around. So when you're in VR, we want now the objects to appear in a sort of meaningful position. So we'll come over here and move it. And I want to standardize for all the objects. I want them 70 centimeters up from the floor, like height at 70 centimeters. So if we have this number here, okay, like this, okay, I need to add 70 centimeters. So it's this plus 0.7. Okay, that's if you want to be very precise. You can also just drag it and put it where you want. But the whole point of virtual reality is that we can be extremely precise. We can have complete control of everything. So I'll just do this and add 0.7. And now this is my new coordinate. And I'll paste it in here, okay, like that. And then the z-axis is the blue one right here. I want it 50 centimeters away, so I'm just going to type in 0.5. Okay, now when we are in VR, this is how it's going to look to us. Like we'll be looking at the object like this. So how do we save this? Okay, well, first of all we have to rename this, and it's going to be a plant. So we'll just rename and we'll call it yes plant. And the reason again is that I'm calling some of these yes and some of them no, is that the ones that were not presented in the initial objects will have no in front of them, and it just makes it easier afterwards when you look at the markers come in. All right, so anyway, at this point I can just save only the selected object. Okay, yes planned. And you see here that I've already done this a lot of times. So if we go here to resources for part 2, see I've created this many times. In fact, I have 15 objects. Well, actually, I have 20 objects. I have 15 that were presented during exposure in the first part, and then 5 that were not presented. So I just do this a number of times, and I end up with all my objects exactly where I want them to be. So they'll always appear in the same place. So it's a bit tedious, but within about an hour, hour and a half, you have them all. That's how long it took me to get all of those done. So, and you can keep working on this. Like I can grab another one. So I have this one now, but I could get another one like this dog, okay? So I can have multiple ones that I'm working on at the same time, and it's okay if they're overlapping each other. So here's the cute dog, and we just this one seems to have a pretty clean coordinate system, so we just go like this and 0.5, and there is a little bit of an offset we had to fix, and then we make it smaller. But you can just keep working on object after object and then exporting them. All right, that's the way. And I've created a video clip which we'll post online afterwards, which shows this entire process for multiple objects. Okay, so you can follow this afterwards and you can see how it's made. So once we make this selection of objects, okay, and it's a whole lot of objects, right? So let's come over here and go into objects. See, it's all these objects there, right? There are some of them have no and some of them have yes. Then we run this part of the software model viewer, and it has its own media configuration file. So we go and check, what is it? It's media configuration file. Okay, and here we can say we have to modify this for the question we want to ask after each stimulus presentation. So we're going to ask, have you seen this object before? And then these are the possible answers. It's completely user modifiable. So we change these, and it can be any question and any answer we want. And then here we have options to present either on a timer or by clicking a button. I am presenting it via timer. So you always have 5 seconds. Okay, 5 seconds. And of course, you can randomize. Okay. So in random order, all the objects will be shown, and then we just respond. And that's really like all it is, because these are, again, these are essentially some of the starter scripts. How to change these parameters is described in the tutorial, but I'm just showing you visually now during the webinar how to do it, but it's very straightforward. That's all we have to do to replicate that behavior of showing model after model and the participant answering, all in the meantime receiving in the acknowledged software markers for when each object was presented. So we can see there's a different physiological reaction when a new object is presented, right? Versus an object that was seen before. Okay, so that's basically here for adding questions, what we have to do. All right, well, before we go to our last poll, I'll just mention a few things. We can also log behavioral movement data if we're looking at head orientation, gaze. If we actually allow participants to walk, we can have logging of the data, but basically additional capability such as working with 360-degree images and videos, configuring list of stimuli via text file. It's too much beyond, too much to cover within the 1 hour we have right now. I hope this, however, gives a pretty complete idea of an experiment. So let's go to our next poll.
All righty, here we go. Launching the poll. All right, so here's a question. A few people asked about this actually. How can you use VR for ergonomics research, lifting and moving things, configuring places for pilots to sit, that sort of thing?
Yeah, so for ergonomics, you can, because you can grab objects and you can make, there's different kinds of applications, right? Maybe you're looking at packaging and or assembly line. So because you can have these motions of grabbing, it can be very instructive, and you can change the position relative to the user for different things they have to reach for, and then you can also record with biosensors to see what's going on. If you're just looking at some sort of interface, this was one example that I showed previously. Maybe I can pull it up real quick.
Okay, hang on, let me see. Okay, yeah, I can go ahead and close the poll now. Thanks everyone for participating. Lots of people, most people are interested in biofeedback, just so you know.
Okay. So like this is now in running in just desktop mode. I'll choose one of the default models here. It's just a Jeep. It's a car model. It gives a pretty good idea. I think it relates to what is being asked. And we'll just run it now. Okay, so now I'm inside a vehicle, and when I look at different parts of the vehicle, like the radio right here on the bottom left corner, we can see that it says gaze fixed radio. And then here now we're looking at the instrument panel, and here we're looking at the mirror. Here we're looking at the rear view mirror and so forth. So we can configure different parts of the world to be what we call regions of interest. So we can see, okay, something happens, how long does it take to look at different things and so forth. Anyway, it's kind of a very long answer, but because there's a lot of applications, but this is probably one of those applications where you can definitely do a lot without coding, like what we are allowing you to do.
Okay, great.
Yeah, I think at this point we can just see if there's questions, and we've covered the I think the creation of the experiment that was discussed in the beginning. There's always so many more things that can be done. Of course, there's only one thing that I can show you today. And I'm curious to get feedback from everybody who attended if this way of presenting the capabilities of the platform helped them learn.
Yeah, and you all can just comment on that right now in the questions pane. So
And what else you want to know, right? Because we can address this afterwards with like video clips or Q&A.
Yeah, there's a survey at the end. When you close the GoToWebinar, you can see a survey, and there'll be some opportunity for you to give us comments, but feel free to just give us comments right now as well. I mentioned earlier about hosting and attending workshops at locations all over the world. Let us know if that's something that you're interested in, and you already answered the poll, so we'll have that information as well. Now let me go on to the Q&A, and Alex, if you need me to show your screen again, just let me know. So Mark had asked a question earlier about doing research related to cognitive and emotional responses to spatial audio. How would something like this help him with that?
Yeah, so you can have spatial audio within the VR system. So you can actually have audio tied to a specific object, like maybe it's a duck or a car that's passing by. So we can tie audio to objects, and that's the sort of thing that will be helpful for spatial audio. Of course, without knowing more details, I'm not sure how much I can comment, but there's tools in the software that address those issues.
Okay, and then what about sample rates of the sensors? Is that something you want to cover?
Well, it depends which sensors. So they're the sensors for measuring physiological data, and so those have sample rates that are selectable. The wireless ones are 2000 hertz maximum. The other ones, the wired ones, can go very high. As far as the virtual reality frame rate, it depends on the HMD. So it can be 72 hertz, 90 hertz. If using the Quest 3, you can go to 120 hertz. So it depends on the exact HMD model, but definitely smooth enough for a good experience.
Okay, great. And then Ryan asks, can you have timed meeting of objects for certain sensory perceptions? Wait, it's cut off. Okay, if I want to know when the user was going to interact with an object.
Right, so we can both log as text as well as send information within Acknowledge if you're recording physiology at the same time, whenever a number of things happen. Whenever you enter what we call like a proximity zone, so as you're moving and you're maybe passing through a door in virtual reality and there's a trigger, or your hand or a controller is passing through an object, or when you're grabbing an object, or when you're looking at an object. So these sort of things are already you can do using templates that exist. For anything more complicated, you have to code it in, but these sort of behaviors, you can just copy and paste from examples.
Okay, and Eleni asks, how do you access your data after you finish running your participant or trial?
Yeah, so there's a whole lot of data, right, that can be coming out of this. It may make sense actually to switch over to my screen so I can demonstrate.
Oh.
Okay. All right. So data, we can see here we have some data files that were coming out from what we were running. So let's see. 6:24 p.m. I think that's one of the ones. It's one of those. No, I think, yeah, I think this one was from the experiment. So here we have a bunch of data that's coming out in Excel file. Here we have data that's coming out just in text format. So let's just have it load. It's quite a lot of data in this particular case. Okay, so so we have, okay, it's Well, okay, I closed it before it managed to load everything. But we have pupil width data. I mean, we can have data on movement inside the environment. So everything is can be saved in a format that you can easily access, like text, CSV, including the face tracking data. But it makes sense for some of the data to be, if you're using also acknowledge, if you're recording physiology, for some of the data to be then also loaded alongside the physiological data, and that you can do as well. So just many ways to handle that. Yeah.
Okay, so let's just take a couple of other questions here. Okay, so a couple people asked about training for athletes and sports, or sorry, applications for athletes training and sports. How does the VR work? Is VR a good option for that sort of thing? Can you address that as well?
Yeah, so there's lots of different examples of how you can use VR for that. You can you can use virtual reality to, for example, play back something in 360-degree video and have participants immersed in it. So let's see if I can quickly show an example from something like that. So we have media. Okay, yeah, I could probably find an example here, but okay, I was going to show an example similar to that, but it would take me a bit of time. More VR-centric application would be, for example, improving on reaction time, which can help a lot with training athletes. For instance, imagine you have a number of targets around you, and then a target flashes, and then you have to throw a ball. And this is something I showed and hit the target, right? This is something that I showed as capability in the previous part, like using physics. But even if it's not physics, because you can know when your hand passes through an object, you can have reaction time tasks where you have to quickly go to the object that you have to go to and hit it, for example, right? A virtual object. And these sort of paradigms are used for training athletes. And this is sort of the things that come to the top of my mind right now.
Okay. Well, we do have that other webinar, and I did send everybody a link to that webinar just now. So if you didn't watch that last week, or if you want to rewatch it, feel free to click that link, and I'll also show that on my screen. But one last question from Colby. Can you go in a little more depth as to why you rename objects yes or no with the underscore?
Right. Okay. So the reason I renamed the objects to have a yes and a no in front of them is that I wanted to keep track of which objects I'm showing in the first part of the experiment. These are the objects that were in the living rooms, and the ones I have no, they are not they're not shown during this part. So okay, then during the recall phase of the experiment, you have some objects that were seen before and some that were not seen before. Okay, if we're running at the same time the acknowledge software, we're gonna get markers that give us the names of the objects. Okay, and if I have then I have a very easy way. Some of the objects will say no, and some will say yes, and then I can say, all right, let's look at our heart rate every time I look at an unfamiliar object, right? So then in our software, I can search for all those markers that start with no, okay? And then I can get, oh, heart rate is higher when we have an unfamiliar object, or vice versa, who knows, right? So it just makes data analysis easier. That's the only reason, really. Otherwise, you can name them whatever you want, but if you do it like this and you tie it with physiological data, it just makes data analysis easier.
Okay. All right. Well, I'm going to make myself a presenter because I have a few things that I want to cover with you. The rest of the questions, I know Colby and Rolando and Deep T, you all have questions that we'll follow up with you offline. it would be best to have a conversation about those sort of things. I see Fraser, answering some questions in the background there. So before I go to my closing comments, I wanted to share a couple of things on our website. This is the part 1 webinar that I just sent the link out to, and there's also a bunch of other webinars. We have over 100 webinars on our website and a bunch of virtual reality webinars and StimPres and eye tracking and all kinds of things on here. So feel free to visit this page and select any of these webinars to watch. There's also this VR resources page that we set up with scripts and different resources from Alex to get going on VR. And then I don't know if this is the system that you showed today, Alex, but we have products.
Correct. So there's options like it can be for 1 user, 2 users, it can be multiple users, right?
Yeah, and then if you just search for VR on our website, you'll find a list of products there. So we're happy to talk to you and answer questions, though. The way to reach out to a salesperson right away, actually, or an account representative, on any page on our website, you can go down to this form and press contact, and it immediately sends an email to your local representative, wherever you are in the world. Someone will reach out to you to follow up. Okay, so let's see what else we have here, Alex. I think that might be a wrap.
Yeah, that's about it. I just, once you mentioned that, if we know what your application is, what sort of experiments you're planning, then we can comment on the feasibility, right? If it's something that it can be easily done, leveraging using existing capability of the system, or maybe it's too complicated, who knows, right? So we would love to have those conversations. This is everybody has very exciting, interesting projects, and we want to help make them happen.
Great. Well, thank you so much for putting all of those environments together, showing how to put an environment together. I know that's a lot of work, and we do appreciate the thoroughness that you went through to get this presentation together today. So thank you, Alex. We do have some great webinar topics coming up. We're working on mindfulness, reaction time. We have a really exciting new emerging technology that we'll talk to you about in the next couple of months. So stay tuned for additional emails from BioPack, or visit our website. Today's webinar was recorded. We'll email you a link to today's recording, as well as the slides and possibly additional information that we think would be appropriate for you to follow up with. When you close the webinar window, please submit our survey. We'd love to have your feedback and ideas. And then, of course, visit BioPack for additional references, including that VR references page, resources page, screencast, application notes, step-by-step instructions, and future events will be at the American Physiological, will be at the American Physiological Society Summit this spring, as well as many conferences throughout the year. So find us in person and we'll show you what we have. This concludes today's webinar, but wait, did you have anything else you wanted to comment on, Alex, before we conclude? No. All right, well, thanks everyone for attending, and we'll see you at the next webinar. Have a great rest of your day. Take care.
Thank you.
Bye.